assign certain positions. So this one is targeting social media managers, and they're saying, here's an opportunity at Coca-Cola. So we've seen it with a lot of other Fortune 500 companies saying, here's this great opportunity for you to use your skills as a social media manager. And they're using context about the targets that they've gathered from open source to say, okay, I know this person to this company is a social media manager, so I'm going to send this highly targeted attack towards them. So we're seeing more and more of this customization about things that in the past would have been a little bit more broad. So this one is a little bit harder to see, so you'll just have to take my word on it. But the one on the left is specifically, I really hope you can see the subject, it's about regulations. And the one on the right is about an intellectual property rights violation. So threat actors are also specifically choosing themes for their emails that may bypass AI. Because one of the areas where some AI struggles is with knowing what to let through, even though it's a little suspicious, and what not to let through. So, for example, if I'm designing AI to block emails coming in, one of the things I'm going to be careful about is anything legal. Because I don't want to accidentally block some sort of legal action because it looks a little bit suspicious. There's a lot more risk to my company blocking something legal than allowing in like 0.1% of emails that are legal themed. So threat actors know this, and they're really starting to take advantage of it. We're seeing a lot more of these legal, copyright, regulation-themed ones that are, something that AI is going to be a little more likely to let through just to cover their own ass. So another thing we're seeing a lot of is password protection of archives. So this is most common, of course, with malware, but we're also seeing it with a little bit of credential phishing. And it seems simple. You just put a password in the email body, and then you have some kind of downloaded archive or attached archive, and you have to use the password. It used to be that this took a little bit more effort, especially if the threat actor wanted to generate unique passwords for each email in the campaign. But now, with all these emails being so easily generated, you can have a unique password for every single email in your 2,000 email campaign, which makes it a lot harder for defenders to actually do something because every single time they need to have the original email with the password in it. So another thing we're seeing a lot of course, is attachments with links. So here we've got a nice little PDF with a link in it. But it used to be a little bit less common to see attachments with links because there was no real point. If you were going to have an attachment that did something, you might as well make it deliver malware or make it do something else rather than just have a link in it. But attachments, especially PDFs that have links, and also password protected attachments, like hopefully you can see here, are becoming increasingly common because it's a lot harder to just block PDFs because they have so many legitimate business purposes. You can't just say, all right, that looks suspicious, just gonna block them. So it's a lot easier for threat actors to take advantage of that. So this one, hopefully I made this big enough, is a new technique that we're seeing that is very successful at getting past SEGs. And what they're doing is they're artificially messing with the header and footer of attached archives. So up here, you can see with a little red box around it, it says .png. So the SEG, or whatever security appliance you have, looks at the email, scans the attached archive, and says, oh, there's an image inside of the archive. Perfectly fine, and it lets it through. But here at the footer, we've got .exe. So once it gets through, once it gets on your desktop, you use WinRAR, you use whatever your little tool is, you pull it out. Suddenly, you've got an executable. So just by changing 3 little letters, .png to .exe, threat actors have pretty easily bypassed quite a few SEGs. And it's becoming increasingly common and increasingly annoying because these executables are not subtle. Like, you run them and they're immediately obviously bad. But just because of changing those 3 letters, they're getting through. So of course, I'm sure you all have all heard about QR codes. You know, they're becoming an increasing problem, and they're starting to get really annoying. But where AI kicks in here is we're seeing unique QR codes generated in each email. So this campaign was sent to a couple hundred people in an organization. You know, looks important, HR notification, etc. And each email had an attached PDF with a QR code. but every single QR code was unique to the recipient. That's a lot more effort than a human is typically going to go to. I mean, technically, they could go to that much effort, manually generating each QR code, importing it, and all that other stuff, but that kind of scale and a unique QR code for each and every individual one leading to a credential phishing page is not something I would expect of actual humans. And we're seeing increasing usage of this sort of thing, this kind of customization beyond normal human scale. So another tactic we're seeing here is putting links in images. So this is all obviously in Chinese, but we have this nice little URL here. So the thing is, this URL is not clickable. You have to go in and actually type it out yourself. So believe it or not, just by making people type in the URL and putting it in an image, they're bypassing a lot of security restrictions because there's no URL to scan. If you're using, optical text recognition, that kind of thing, sure, you'll see the URL, but a rather concerning number of SIGs are not actually using that, even though we really should. So we're seeing stuff like this get through, increasingly more common. So now I'm going to talk a little bit more about URL-based TTPs. So these are things that threat actors do to the URLs embedded in the emails and the URLs that actually lead to credential phishing sites. So this one is particularly troublesome. On the left, you've got a typical Google AMP redirect. So I don't know how many of you are familiar with it, but Google AMP lets you redirect very easily. You just put in google.com/amp/s and put in your URL. And just like that, when your security appliance scans the URL, it says, it goes to Google, you're safe. It definitely does not. It redirects immediately to a bad place. But it's really easy for threat actors to do, and it's becoming more common. And honestly, it's just really, really easy to do. So on the right, we have something that I actually find more concerning. This is a government website. You can see the .gov there. This .gov website actually redirects to another .gov website before finally redirecting to the credential phishing website. So threat actors have figured out all these ways to get around SEGs and security appliances, and compromising government websites has recently become a lot more popular. I don't know if this is because a lot of departments are able to spend less on protecting against this sort of thing, or threat actors are becoming a little bit more adept at compromising them, but we're seeing increased abuse of this sort of thing. And it's especially bad because when you train your employees and you say, here's what to look for in a link, here's what's safe, one of the things that people consistently say is, it's .gov. If you see .gov on a URL, then you know it's safe. Unfortunately, that's no longer true. So this is a clever technique that we've been seeing recently. So on top, you've got the encoded URL with a redirect. I don't know how well you can see the %E3, %80, %82. So what that decodes to is the URL here at the bottom. And you may notice there are these little circular dots, but they're not dots like you expect. They're not .com. So with most security appliances, they scan this and they say, okay, that's not a URL. It's not .com. So I don't need to really bother with this. I can just allow it. The thing is, if you go to your browser and you put in that special character, your browser interprets that special character as a dot. So you do actually go to awl-mx.com. So it's another way threat actors have figured out where the disconnects are between automated scanning and automated following of links and how humans actually visit the links and the tools that we use to see them. And this sort of thing is actually relatively easy to do to your URLs once you start sending them out. And especially if you start using any kind of at-scale AI generation for these things, it's incredibly easy. So this is another thing that we've started seeing very recently. This is a little bit more of an emerging TTP. So on top, you can see the very long URL, but I've highlighted the important part that's in little script tags. So you can see here script and script. So that's actually JavaScript that is being run by this website. So it decodes into this href, which is a redirect. But because it's not an actual typical redirect, if some kind of SEG scans this, they're going to say that's not a redirect, I don't need to follow it. So they're going to say, okay, this .edu website is legitimate, and they're just going to allow it through. But in reality, the threat actors are using this base64 encoding to ensure that your browser executes this JavaScript and takes you to this credential phishing website. So now I'm going to talk a little bit about second stage TTPs. These are things that happen after you've got the email and you've clicked the link, when you're at the actual credential phishing page. These are a little bit harder to defend against because you've already visited the web page, but there's still something you can do stuff about if you work at it. So this one, I'm sure you all have seen things like this before. This is a legitimate host. This is forms.cloud.microsoft.com. It's on, again, Microsoft.com. That's pretty legitimate. Even some of your users who are typically suspicious will probably see Microsoft.com and say, okay, it's fine. I can click these links, I can interact with it. So it's got this nice little, you've received a document, the little message. But most importantly, down here, it's got a clickable link to what is definitely not legitimate, and that's the actual credential phishing page. But by hosting it on Microsoft.com or Google Slides or whatever the particular place the threat actors choose, they're tricking both your seg scanning and your trained employees because, again, you train them to say, okay, is this a legitimate website? And they look at the URL and they say, okay, it is. I've looked at the domain, everything looks legitimate. So they think, okay, from here on out, I don't need to keep being suspicious. I only need to be suspicious of this first step. So this we've seen a lot more of, especially down at the bottom, this try Cloudflare here. This is what we call quick deploy hosting. And Cloudflare advertises it. They all do, but Cloudflare especially advertises it, where threat actors can deploy websites with one line of code. They literally just type in one line. Their website is completely deployed to some new subdomain on Cloudflare, and it's up for however long until it gets reported, and then they go back and they just redeploy it. There's no any kind of real checking as far as I can tell. We've got all these different ones. I assume Windows.net does some checking, but honestly, they don't seem to be super great at it because we see a lot of stuff hosted on Windows.net. So all of these quick deploy hosting things are obviously quick to deploy, but they're also quick to take down. So as soon as the threat actors have sent out their emails, they've looked for people putting in their credentials, they can say, okay, I've gotten 50 credentials. I don't need more. And they'll take down their site. And just like that, they've made it very difficult for anybody in a SOC, anybody who's analyzing these, because all of a sudden, the site they were going to do the research on, they were going to figure out where the credentials go, it's down. There's nothing they can do. They've just completely stopped the chain of events. So once they do that, then they quickly send out another campaign, quickly deploy it, and then take it down. And it's just a really easy cycle to do. And obviously, there's a lot of different choices, and most of these are free. You can create an account, and then I think most of them it's like 7 or 14 days, and you can deploy all you want. So it's very easy to do. There's really no cost other than time to threat actors. And if you automate this, it's a breeze. You just automate it, and you're good to go. So obviously, we talked about legitimate services hosting links to malicious places, but I also want to talk about legitimate services hosting malicious files. So we see this a lot with malware. So here's obviously something hosted on Google Drive, but the key thing is it says Google Drive can't scan this file. It says it's a multi-volume archive. So Google is pretty good. They usually have pretty quick takedowns of malicious files once they're reported. But the thing is, threat actors have found a lot of ways, Google Drive, OneDrive, there's a whole list of them, where if you tinker with the file you're uploading just right, the service doesn't scan it. They just put it up there so anyone can download it. So in this case, with Google Drive, all you have to do is, obviously password protect it, because they love doing that, or just put it inside of another archive. That's all you got to do. A couple of archive layers, and Google says, can't scan it. Do you want it? And they just give it to you. So this is another instance of there being a free service that threat actors can use that, sure, it may go down quickly, but if you send it out and have it up right after you send out your email campaigns, you're still going to get quite a few people downloading these links or downloading these files. So one of the things that for quite some time a lot of security appliances relied on was domain age. In my department, up until a couple years ago, we cared a lot about domain age. However, domain age is really, it's just not useful anymore. This domain is, I think, 18. This domain is 18 years old. So if something looks at the domain and says 18 years old, it's probably legitimate. But as y'all can see, this is a credential phishing form. This is very obviously not legitimate. But especially the older tools, they depend so much on domain age that threat actors are just really easily abusing that by compromising or buying domains that have been around for a really long time. So I'm sure some of y'all have heard of ClickFix, FileFix, general clipboard poisoning tools. Those have been in the news a lot recently. So this image is actually old. It doesn't really look like this anymore, but I wanted to show y'all where the name ClickFix came from. So you can see here it says ClickFixIt. You click the little fix it, malicious code gets copied to your clipboard, and then Windows is very nice and makes it very easy to run things from command line. Even if you know nothing about your computer, you just tap a little button combination here and you run a malicious command line. And that sort of thing is a lot harder to block than downloading a file, visiting a malicious website, doing whatever, because all it uses is clipboard and built-in utilities that typically are not just going to be flat blocked. So ClickFix, FileFix, generally clipboard poisoning, it's another way that threat actors have found to just avoid the defenses, because if your defenses are focused on saying, here's a bad website, we're just going to block anyone visiting it, or your defenses say, here's an MD5 hash. If there's this hash, I'm going to block it. Then that's not really going to help when people use command line and run things in memory. So just by using this little ClickFixit thing, which is now a pretty cheap kit to buy, threat actors can easily bypass just about anything that's MD5 or SHA-256 based because they don't leave hashes. So this is something that we thankfully don't see a lot of, and not a lot of people are familiar with it. It's called a blob URI or URL, whichever you prefer. So if you look up here at the bar, it says blob followed by this. So what this does is it basically generates an HTML page locally. So what that means is if your, say, security appliance, whatever, scans this BritishCouncil.org, etc., it's not going to see anything. This blob only renders in browser. It only loads up when it's visited. So if that path gets scanned, it's going to come up as legitimate. So your service is going to say, sure, people can visit this. There's nothing malicious here. But the moment they visit it, it loads this local blob into the browser, and you've got a credential phishing page. As I'm sure y'all can see, this is one of the many pretty generic credential phishing pages. So now I'm going to talk a little bit more about the kits. So this is pretty complex. I know that not all of y'all see code like this on a daily basis, so you don't really have to understand all of it. The key part here is this little string, localization data, no languages detected, and down here at the bottom it says localization data, time zone / language mismatch. So what the threat actors are doing here is they're looking at the browser language of whatever browser is visiting their web page, and they're checking the language and they're checking the timestamp to see, is somebody analyzing my credential phishing page? So what this does is it allows them to relatively easily see if the person looking at their page is an analyst or a victim. And what that means is that if it's an analyst, they can immediately redirect you to Wikipedia, Microsoft, wherever they think is legitimate, and make it so that analyzing their page and figuring out where their credentials are being exfiltrated to is almost impossible, because it does this so quick. It just, you visit the page, checks your language, and immediately redirects you. And This is especially common in Latin American countries. Y'all probably don't have to worry about that too much here, but my company is international, so we deal with a lot of Latin American stuff, and almost every page has a language check. So unless your language is coming off as Portuguese Brazil, you'll get redirected 9 times out of 10. It's very common in Latin America, and it's becoming more common here too, because if, say, you've got someone in the UK and you're analyzing it, then sure, the language would check, but this time zone language mismatch, that would still ding you. So another thing, of course, is user agent filtering. So this is both to stop analysis, but also to customize the delivery. So in this case, it says access restricted, only available on Windows devices. But what we also see is websites that say, okay, your user agent is Android. I'm going to give you a Zoom, or it's named Zoom APK, which is Android malware. Or it says, you know, your browser user agent is Mac, so I'm going to give you some Mac-based malware. So they customize their websites based on what device you're visiting from. In the past, if you were, say, visiting a credential phishing website using your phone, it might be a little more obvious it's credential phishing because of how the forms are spaced out and that sort of thing. And it would be a little bit more suspicious. But now, they give everyone who visits their own little unique experience to make sure that they get you. So this is specifically geolocation filtering, which they also do a lot of. Here on the left, it's Wikipedia. The current favorite is if they detect you're coming from a region, whether it's a state or a country outside of their target, they will just send you to a random Wikipedia page. I don't know why. It makes it very obvious there's malicious stuff going on, but that's what they do. And it makes it easy for your SOC to say that's malicious, but it makes it harder for them to actually have something they can point to and say, okay, here's the URL. You know, I've seen this behavior. I know this is malicious. Instead, they're saying, well, it goes to Wikipedia. I mean, I don't know how many legitimate places do that, but. And then over here, on the right side, it's a little bit harder to see. So what this one is doing is it's checking the IP address, and then it's updating using Telegram. So in this case, what happened is if you visited this particular page spoofing the Social Security Administration, it would check your geolocation, update a Telegram chat saying someone from this geolocation downloaded your ConnectWise remote access tool. Here's some additional information on them. So the threat actors know that if a computer from that geolocation starts running ConnectWise, then it's one that's actually been infected. Whereas if ConnectWise is running from an IP address that hasn't been reported, from a geolocation that hasn't been reported by this little tool, then it's probably someone analyzing it, so they can just immediately terminate the program and try not to give away anything. So something that is, as I said earlier, it's hard to say for certain whether something is AI or not, but this is another one of those cases where the customization is so high that it's very unlikely an actual human is doing it. So what we're seeing a lot of is email address filtering. So what this means is that when you click a link in an email, you go to a page, it asks you email address. So this is problematic for 3 main reasons I've got here on the left. The first is domain tailoring. So that means if I go and put my email address in here, it will cater the login page to look like my company login page. It's pretty easy to just scrape that. Hello? Nonsense. Okay, it's pretty easy to scrape that data online and customize the login form so they can immediately make it a lot more obvious to you at least that, hey, this is legitimate. It's got my organization's image on the back. It's got all this stuff that looks legitimate. So the second thing they can do is verification. So what this means is that when you actually visit the website, if you don't, oh, sweet, much better. Thank you. So if you visit the website and you put in an email address that is not the recipient's,
they know that you're an analyst, so they just immediately block you. They try and hide everything they're doing, and they make analysis very difficult. So this actually goes into the final point, SOC avoidance. So a lot of SOCs, unfortunately, when they get IOCs, they are simply given a URL. They are not given the context. They're not given the email that was reported. They're just given a URL. They said, okay, this is suspicious, analyze it. So that really prevents them from providing context and doesn't give them the context they need, which is really important. So the context is, here's the email address of the recipient. And if the analyst has the email address of the recipient, they can go in here, they can enter it, and they can actually progress through the phishing, gather all the information they need. If they don't have the email address of the recipient, they're completely stuck here. They can guess maybe like 50 times, but there's really only so much they can do. So that context is really important. I'm not going to waste time on this one. We see a lot of CAPTCHA. Everybody knows CAPTCHA. It's becoming more common. It's free, super easy. Everybody uses it now. If you don't use it, you're not putting in the effort. So here's a nice long list of anti-analysis TTPs. So with the screenshots I showed you all earlier, some of the tools that threat actors use, here are some of the more common ones. So detecting developer tools, that's really easy. And a lot of times SOCs use developer tools because it's already built into the browser. You don't have to put a lot of effort into it. There's other things, screen size, performance metric, all this other stuff. So there's even more than I've got listed here. But I just want to show you all this rather large list so you get an idea of all of the different things that threat actors can do to check if they're being analyzed. And all of these things are easy to do. There's free kits out there. There's more advanced kits. The free ones probably only do like 3 of these. But the advanced ones, especially the AI-generated ones, they do all of these things. So one of them recently that is likely AI-generated goes so far as to give you a score. And it checks each of these different things. And if you pass, you get a half point. If you fail and it thinks you're an analyst, you get a full point. And then it adds up the points from each of these checks and then says, okay, this person's an analyst. I'm going to redirect them to a legitimate page and make it seem like I'm not doing anything suspicious. So the more advanced these tools are, the more of these different capabilities they use, and the harder it is to analyze them. So here's what I was talking about in the beginning, some of the things that I really wanted to cover. So this is first just some general mitigations. So first, you really need to find a source of contextual intelligence. Obviously, as I said at the start, I'm manager of an intelligence analysis department, so use our product. But if you don't, you do need to find some source of contextual intelligence. You need to know more than this one URL is bad, because saying this one URL is bad, I mean, it's important, but not as important as being able to say, I have this whole chain of events. So I know this one person clicked this link, and because we have this analysis with context, I can say then they probably went to this website, they probably gave these credentials specifically, and it was probably exfiltrated to this location. So when you've got this context, it's so much more helpful. And it's especially the case with malware, because if you're using something that just uses hashes, so say you get a ConnectWise remote access tool, and the hash is already listed, and your system goes, okay, I know this hash, and it blocks it. Great, you blocked it. But if they've slightly differently generated it, and they've given you a slightly different hash, which is really common, because especially with AI, it's really easy to do, then you've got something that is unidentified in your environment, and you don't have the context, you don't have this is the command and control center it reaches out to, this is the things that the files do, you don't have the other context that you need to identify it and remediate it. You don't have those tools that really help you handle it as best as you can. So I've got an example of context. I use ConnectWise remote access tool as an example a lot because we see a lot of it. Because some organizations use ConnectWise as a legitimate tool from their administration, IT admin department. It's like what they actually use. Not a lot of them, but some of them. So somebody who doesn't know any better will see it and they'll say, oh, this is probably from IT. I'm going to run it. Because they don't have the context. They don't know that, no, IT definitely does not use ConnectWise, and it's a very bad idea to run it. Whereas if you just got a very simple list of the remote access tools that your IT department uses, people can easily go, okay, maybe I shouldn't run this. So the second point is really important. If you've got some tool that says, okay, this URL has been analyzed, I'm going to block it. I'm going to block the domain, I'm going to block whatever. So people click a link and they go to it. You've blocked the first part. You've blocked them entering their credentials because they can't go to the website. But it's critical that you also remove the actual emails from the inboxes. This is a little bit harder. And I'm not really clear on why, but there's not a lot of tools that do a good job of removing all of the emails from all of your employees' inboxes that have a specific URL. So this is important because there can be multiple URLs in an email. And say one of them is consistent, well, maybe your second one is customized to each individual employee. So your tool that blocks access to the first website isn't really going to help with the second website. But if you've got a tool that just completely removes the emails from the inboxes, you've just completely cut off an attack vector. So this one is not as related to everything else I've said, but use a password manager. It's a big deal. And one of the things people don't think about is password managers actually provide you with a level of protection from credential phishing, because if you get the right password manager, what it does is it checks the domain of the page you're visiting. So if you visit a credential phishing website, your password manager is not going to autofill your credentials for you. But if you visit the actual website, your password manager is. So just by having that thing autofill or not autofill for you, you've provided a whole other layer of defense. So next up, use phishing simulations based on evolving threats. So this is really key because some vendors for their SIMs use emails that are a little bit older, or even ones that are newer, but they're ones that get caught by SEGs. And honestly, that's pretty much useless. If you're using emails that get caught by SEGs, then your employee is never going to see it. So training on something that they're never going to see just doesn't really provide any return on investment. It's not actually preparing them for the threats that are going to be in their inboxes. You need to find something that is based on things that bypass SEGs, things that end up in inboxes. So part of this is train employees to protect other employees. So if you've got one person who, for whatever reason, just cannot help themselves, and they have to click every single link, no matter how much you train them, if you have somebody who is very good at spotting these things and reports them, when they report these things, they get analyzed, and then you use this little tool to pull it out of the inboxes, then that one person who clicks every single link is not going to have the opportunity to click the link because they won't even see the email. It'll be gone before they start doing their little thing. So another key thing here relating to using phishing sims is employees who are trained to be suspicious of emails are going to be suspicious in general. So that means vishing, smishing, etc. They're going to be more trained to have critical thinking skills that make them go, maybe this isn't right. So it's not going to be just credential phishing, but it'll also apply to BEC. So they'll say, all right, I'm used to getting this kind of thing. Let me check. Am I being rushed? Have I been given a deadline of 2 hours? Is this suspicious? So that kind of training really bleeds over from phishing simulations into all areas of just good cyber hygiene. So these are some SOC-focused mitigations. First one is obviously use tools to bypass these different methods, especially that large one that I laid out for you with all those little options. There's tools to bypass these. So first, to give you some really specific options, user agent switcher and manager. This lets you check, for starters, if the web page is serving different content based on different user agents, but it also lets you use whatever analysis browser you want. So then you've got locale switcher. This lets you change your language. This is most helpful for international companies, but it's also just good to have because it allows you to handle a lot more. The next one is really important, providing SOCs with multiple VPNs. Threat actors do have some VPNs mapped. Luckily, they don't really play nice, so a lot of them have not coordinated. We have found several times we will be analyzing something using one VPN provider, and all the connections, all the endpoints will have been mapped. So we visit the website, no matter what we do, they block us immediately. Couldn't figure it out. We switched to a different VPN provider. Turns out they were not mapped, so we could get everything we needed. So VPN licenses, they're not that expensive, and just having two separate options really opens you up and allows a lot more things. Especially, I want to emphasize, they need to switch their VPNs based on context and email language. So this last one, physical machines, this is especially important for malware because most modern malware has built-in VM checks. It is very easy to check if you're in a virtual machine. It really doesn't take any effort. If a threat actor is not checking if you're in a VM, then they're really not putting in the effort. So it's very easy to check. So using physical machines that you just re-image after analysis is a really good way around it. And that sounds, oh, it must be expensive. It's not. It's really not. You can just use, honestly, old laptops that are no longer new enough for employees to use and use some kind of software like, I think it's Mesh Agent is a popular one. There's all kinds of free software out there. So all you need to do is just use any old physical machine and re-image it. And this is especially useful for ransomware because there's a lot of ransomware that will not run in a virtual environment. So if you run it in a VM, if you've got your SOC analyzing it, your SOC is going to say, this is fine, this isn't malicious. And if you run that in your actual environment, you're SOL, like you just got ransomware. So you need to have a way around those checks. And there's a lot of stuff you can try. Some of it works, some of it doesn't. But the easiest thing is to just use a really small, cheap physical machine. So this last one, I talked about earlier. I really cannot emphasize it enough. SOCs need to have context. They need to have the email because they can get so much more done with the email. So whether this is knowing the email language so they can use the right browser language and actually get the phish, or whether it's knowing, okay, this was sent to someone in Virginia, so I need to have my VPN location be in Virginia. Or, okay, so I know this person's address that it was sent to, so I can actually get through the different checks and get the credential phishing page. So giving them context beyond just URLs is really key if you want full performance. I mean, if you just give them the URL, you'll get the baseline stuff, but you're really opening yourself up to a lot of different things that can just easily be solved by giving them the context. So I added some relevant links at the ends for anybody who gets the PDF of this. That's what I got. Does anybody have any questions? All right.